Okay, let's take a look at an example that has to do with linearization. The previous video talked about where this particular formula comes from, so if you haven't seen that yet and you're interested in where the formula comes from, you can go back and watch that video. So I have f of x is this one, and I have the x value is -3. So what I need to find is I need to find f of a, which means that the a value in this case is going to be -3. So let's do that first. Let's first find f of -3. Okay, so if I do that, I put -3 into here. -3 squared is 9. 9 plus 16, 25. Therefore, square root of 25 is 5. So now I know this part of the formula right here. Now the other part that I need is f primed of a. So I need to take the derivative, and I need to put -3 into the derivative. So let's do that first. Now, something like this, because I have something inside and I have something outside, this is where you want to use chain rule that we talked about earlier in this section. Okay, so for this, what I'm going to do first is I'm going to rewrite f of x as x squared plus 16 to the 1/2 power, and then I'm going to go ahead and take the derivative by using chain rule. So chain rule, you got to start with the outside function, so the 1/2 comes down, so f primed of x is 1/2 x squared plus 16. Subtract 1 from the power and you get -1/2, and you're going to multiply it by the derivative of the inside. Derivative of the inside is going to be 2x. If I simplify it further, then I get f primed of x is going to equal, x's cancel, I'll get x over the square root of x squared plus 16, and that right there is going to be my derivative function. Now I want to find f primed of a, which means that I want to find f primed of -3. So then what I'll do is I'll put -3 in for both the x's. So I have -3 on top, and then I have square root of -3 squared plus 16 down below. And if I work this out, I get -3, and then this we know is going to be, we already did that earlier up here. If I put -3 inside here, I'll get a 5. So -3/5 now is going to be the slope that I want to use. So now I have this information, and I have this information here. I can put that directly into my linearization. So L of x is going to equal f of a is going to be 5 plus f primed of a is this slope right here, -3/5. So I'll put that in there so I can change this to a minus 3/5. And then I have x minus a. So I have x minus -3. That's going to give us a +3 right there, and that's going to be your linearization. Now, depending on the online homework system that you're using, it may require you to put this into y equals mx plus b, or slope-intercept form. So we'll go ahead and we'll do that for this one. Okay, so L of x, we have 5. We'll distribute the -3/5. So we're going to do -3/5 x, and then minus 9/5. And then we're going to simplify this further. We're going to do 5 minus 9/5, and we can get our answer here. So -3/5 x. And then over here I have 9/5, and then I can make that, technically that's 25/5. So if I have 25 minus 9, that's going to give us 16/5 left. So this right here would be your linearization in slope-intercept form. Okay, we want to find linearization sine x, so we have a trig one this time, and the value we have is pi over 6. We're following this linearization formula. First one I'll do in that formula is I need f of a, so that means I want to find f of pi over 6. So I'm going to put pi over 6 into x in the original one, and that's going to allow me to get my f of a. So this is going to be the same thing as sine of 30 degrees, which we know is going to be 1/2 off of the unit circle. So f of pi over 6, 1/2. Next, I want to find the derivative, and I want to put pi over 6 into it. So my derivative of sine x is going to be cosine x, and now I'm going to put pi over 6 into here. So again, the a value I have here is going to be pi over 6. Okay, so I'm going to do f primed of pi over 6 is going to be cosine pi over 6, and that's going to be root 3 over 2 using a unit circle. Okay, sine is 1/2 and cosine is square root of 3 over 2 when you're looking at pi over 6. Okay, so now we have these two values. We're going to plug them into here. Okay, so L of x. Okay, f of a, the a value we said was pi over 6, so we're just going to write 1/2 there. F prime of a, that's our root 3 over 2. So root 3 over 2, and then x minus my a value, again a is pi over 6. So I have this right here. Now it's just a matter of cleaning it up. We're going to put it into the slope-intercept form if it asked for that. So we'll combine this a little bit more. We're going to multiply both things by square root of 3 over 2. And we're going to get root 3 over 2x. And we're going to get minus pi times root 3 all over 12. When we multiply across the top and across the bottom with those fractions, we'll get that. And then we're just going to rearrange it. So L of x is going to equal root 3 over 2x. And then I have plus 1/2 minus pi root 3 over 12. And what you can do is you can leave it in that form. If you'd like to get a common denominator, you can do that as well. Let's do that. Common denominator here, we'll multiply this by 6 over 6. So that way we get one constant in the end and we know what our b value is. That will be 6 minus pi root 3 all over 12. So then we get it to, technically this is the correct form for slope-intercept. Your slope is square root of 3 over 2. And this whole big thing here, that's going to be your y-intercept.